Hello and welcome to the Gravity Lullaby. Have you ever looked up at the night sky, maybe on a quiet evening when the city lights fade, and wondered, just how big is all of this? The stars, the galaxies, the endless black canvas above us. What does it really mean when astronomers say the universe is vast beyond imagination? We throw around words like billions, trillions, light years, and infinite. But do we truly feel what those words represent? Or are they just numbers we nod at without ever grasping their weight? Tonight, we're going on a journey. Not through space in a rocket, but through the imagination and the science that allows us to even attempt to comprehend the incomprehensible. And perhaps, by the end of this journey, you'll see the night sky differently, not as a scattering of dots, but as the grandest mystery ever unfolded before human eyes. So let's begin. Our minds evolved to handle the world at our scale, the size of trees, rivers, mountains, the length of a day, the span of a lifetime. That's what we're wired to understand. But the universe doesn't operate on human terms. It stretches so far beyond our senses that words fail, and even numbers begin to collapse under the weight of enormity. Think about this. The Earth is 12,742 kilometers across. That's big, right? You could fly for hours across continents, yet still be on the same tiny planet. But the Sun, our ordinary star, is 1.4 million kilometers across. You could line up 109 Earths side by side just to match its diameter. And already our intuition starts to fail. Because how do you really feel? The difference between 1,000 and 100,000? It's not something your brain evolved to measure. And that's just the beginning. To truly talk about the universe, we need a tool, and that tool is light. Light travels at 300,000 kilometers per second. It's so fast it can circle the Earth 7 times in a single second. And yet, compared to the universe, light feels painfully slow. From the Sun, it takes light just over 8 minutes to reach us. From the nearest star, Proxima Centauri, it takes 4.24 years. That means when you look at that star, you're not seeing it as it is now. You're seeing it as it was more than 4 years ago. Our galaxy, the Milky Way, is 100,000 light years across. That means if you turned on a flashlight at one end, it would take 100,000 years for its beam to reach the other side. And that's just our neighborhood. The observable universe, the part we can even see, is 93 billion light years across. Numbers like these stretch our imagination until it tears. And yet, they are real. Let's try to climb the cosmic ladder. One step at a time. Start with Earth, a fragile blue sphere suspended in space. Now zoom out. See the moon 384,000 kilometers away. A distance that feels immense to us, but in cosmic terms is a stone's throw. Zoom out again. The Sun dominates, with planets orbiting like tiny beads on invisible strings. If the Sun were the size of a front door, Earth would be a coin just a few steps away. Neptune, the outermost major planet, would be a few blocks down the street. Zoom out further. The solar system itself becomes a speck inside the Milky Way, a galaxy of 400 billion stars, each with its own story. Imagine every star as a grain of sand. The Milky Way would be a beach stretching farther than you can walk in a lifetime. Now zoom out again. The Milky Way is not alone. It's one galaxy among 2 trillion others in the observable universe. Every one of them holds hundreds of billions of stars. And suddenly, Earth feels like less than a whisper in an endless storm. But here's the problem. Your brain can't hold these numbers. They slip through your fingers like water. So let's try something different. Let's feel the scale through comparisons. If the Sun were a grain of sand, Earth would be a tiny speck orbiting less than a centimeter away. The entire solar system would fit inside a coffee cup. The Milky Way galaxy then would stretch the size of North America. And the observable universe? It would be larger than the Earth itself, dwarfing continents and oceans into irrelevance. Or imagine this. If every star in the universe were a single second of time, you would need longer than the entire age of the universe itself to count them. That's how big really is. Now, what about the edge? If the observable universe is 93 billion light years across, does that mean that's the size of everything? Not necessarily. That's just the part we can see, the light that has had time to reach us since the beginning of time. Beyond that, horizon may lie far more universe, maybe infinite, maybe finite, but forever beyond our reach. It's like standing on a beach and looking out at the horizon. The ocean doesn't end there, but that's all you can see. And so, the question lingers. Not only is the universe beyond our comprehension in size, it may be beyond our comprehension in existence itself. Part 6. The human heart against cosmic vastness. Here's where science meets emotion. Because the natural question arises. If the universe is this big, if we are this small, does anything we do matter? Aren't we just dust lost in a cosmic storm? Yes and no. Yes, we are small, insignificant compared to galaxies and black holes and cosmic timescales, but also no, because within us lies the one thing the universe seems desperate to create: awareness. The ability to look up, to wonder, to ask questions like this. Stars burn, galaxies collide, black holes devour, but none of them pause to ask why. Only we do. In that sense, our very ability to feel insignificant is what makes us significant. We are the universe, become conscious of itself. So why even bother? Why wrestle with these impossible numbers and scales we can't fully grasp? Because perspective is power. When you understand the size of the universe, your problems, traffic jams, deadlines, small disagreements shrink into their proper scale. They don't vanish, but they lose their crushing weight. You begin to see life as the rare and precious chance it is. Think of it. You are made of atoms forged in stars, living for a brief moment on a fragile planet, orbiting a star in an unremarkable galaxy, in an unimaginably vast universe. And yet here you are, listening, thinking, existing. Against all odds. That realization doesn't make us meaningless, it makes us miraculous. So, can we truly grasp the size of the universe? The honest answer is no, not fully. Our minds weren't built for infinity, but maybe we don't have to. Maybe it's enough to stand in awe, to stretch our imagination as far as it will go, and then a little farther. Because in the end, the size of the universe isn't just a number to calculate. It's a reminder of wonder, of humility, and of the extraordinary gift of being alive, aware, in the vastness of it all. So the next time you look up at the night sky, remember, you are looking at history, at eternity, at distances. Your mind can't measure, but you are also looking at home. And that's the greatest paradox of all. If you want to understand the size of the universe, you need to begin with something familiar, something you can hold in your mind. Imagine the Earth, our home, a sphere of blue oceans and white clouds, with deserts and mountains scattered across its surface. We've seen pictures from space, the pale blue marble, and we think we understand it. But already, scale begins to slip away. The Earth's diameter is about 12,742 kilometers. That's a number we can read and even say aloud, but our minds weren't built to picture it. To give it a sense of meaning, let's compare. If you were to drive around the Earth's equator at highway speeds, say 100 kilometers per hour, it would take you over 16 days of non-stop driving to circle the planet. 16 days without sleep, without stopping, and only then would. You have wrapped around our little world once. Now, step up. Just beyond Earth lies our moon. The moon feels close, doesn't it? You can look up tonight and see it with your naked eyes. And yet, the distance between Earth and the Moon is about 384,400 kilometers. Put differently, you could fit 30 Earths side by side in that gap. Already, the mind begins to wobble. We see the moon in the sky. We feel as though we could almost reach it, and yet the space between us is unimaginably vast. When Apollo astronauts traveled there in the 1960s and 70s, it took them about 3 days to cover that distance in a high-tech spacecraft moving at thousands of kilometers per hour. And that's just our closest neighbor, the sun, the beating heart of our solar system, is about 150 million kilometers away. Light, the fastest thing in the universe, takes a little over 8 minutes to cross that distance. Imagine that. The warm sunlight on your skin right now is actually a memory, a relic, born on the surface of the sun over 8 minutes ago. When you watch a sunset, you're watching something that already happened in the past. Now, let's push the scale further. Beyond the sun lies the outer edge of our solar system. To reach Pluto, the small, icy dwarf planet that we once considered the 9th planet, you would have to travel about 5.9 billion kilometers. The New Horizons spacecraft, launched by NASA in 2006, flew faster than any probe ever before, yet it still took 9.5 years to arrive. And when it finally sent back pictures of Pluto, they came through the void of space at the speed of light, yet each transmission still took over 4 hours just to reach Earth. Pause here for a moment. Think about what that means. A message from Pluto takes longer to arrive than a long-distance flight across the world. Space itself stretches out distances so large that our ordinary sense of time and travel begins to collapse. But as big as our solar system is, it is still nothing compared to what lies beyond. The nearest star to our sun is Proxima Centauri. It sits 4.24 light-years away. That's about 40 trillion kilometers. Let me repeat that. 40 trillion. If you tried to travel there with the fastest spacecraft humanity has ever built, it would take you tens of thousands of years to arrive. The scale here is brutal. For us, other stars are practically untouchable, eternal pinpricks in the night sky that mock our limited reach. The galaxy, the Milky Way, is filled with stars. Billions upon billions of them. Roughly 100 to 400 billion stars burn within its spiraling arms, and the Milky Way itself stretches about 100,000 light-years across. That means if you started on one side and shot a beam of light directly across, it would take 100,000 years just to reach the other end. Entire human civilizations could rise and fall. Countless generations could live and die. And that single beam of light would still be mid-journey. The scale is so overwhelming that even astronomers often use metaphors to ground it. Imagine the Milky Way as a single disk the size of North America. Our entire solar system would be no larger than a coin placed somewhere in that vast expanse. And yet, here's the part that bends the mind further. Our Milky Way is not alone. It is one galaxy among at least 2 trillion galaxies in the observable universe. Each one carries billions, sometimes trillions of stars. Each one could host countless worlds. The observable universe, the part we can see with our telescopes, stretches for about 93 billion light-years across. 93 billion light-years. The number is almost meaningless. It's a number that slips through our fingers when we try to hold it in our minds, and still, this is only the observable universe. Beyond it, we suspect, lies more, much more, perhaps even an infinite stretch of space we will never see. The light from those distant realms hasn't had time to reach us yet, and it may never will. So when we ask, can we truly grasp the size of the universe? We are really asking whether the human mind, a mind evolved to measure footsteps, river crossings, and horizons, can ever stretch wide enough to hold these numbers. But here's the wonder. Even if we cannot fully hold them, we can glimpse them. We can point our telescopes into the dark and gather the faint whispers of light that have traveled for billions of years to reach us. We can build simulations and maps, showing how galaxies cluster together in webs that stretch across unimaginable distances. And when we see those images, we feel something: awe, fear, humility, a reminder of just how small we really are, and how miraculous it is that we can even ask these questions. But let's not forget, this exploration is not just about looking outward into the cosmos. It's about looking inward as well. Every question we ask about the universe is also a question about ourselves. Every time we chart a new galaxy, we also chart the boundaries of our imagination. Every discovery about the stars brings with it a discovery about what it means to be human. The universe is not merely an external reality. It is a mirror. Its vastness reflects our smallness, but also our potential. Its silence reflects our curiosity, our hunger to fill it with meaning. Its beauty reflects our longing for connection, for belonging in a story greater than ourselves. Can we truly grasp the size of the universe? Perhaps not fully, but maybe we don't need to, because what truly matters is that we try, that we stand under the night sky and feel that shiver of awe, that we stretch our minds until they ache with the effort of imagining infinity, that we pass on the torch of wonder to the next generation, so they too may look up and dream God in the end. The universe doesn't demand that we understand it completely. It invites us to explore, to marvel, to live our brief lives with a sense of grandeur. And if we do that, if we live with our eyes open to the immensity around us, then perhaps we are already grasping something greater than size itself, because the size of the universe is not just about light years or galaxies. It's about perspective. It's about recognizing that we are small, but not insignificant, fragile, but luminous, temporary, but part of an eternal story written in the stars. So tonight, when you see the night sky, pause for a moment. Let your imagination wander beyond the horizon. Picture galaxies spinning in silence, clusters glowing like islands, and cosmic webs stretching like threads of light. And remember, you are part of it. The universe is not just out there. It is in you. Your atoms were born in ancient stars. Your mind is the cosmos reflecting on itself. And maybe, just maybe, that is the most extraordinary thing of all.